Hey guys, tonight we're going to a place where time moves a little differently, and not in the poetic, dreamy sense. We're talking damp stone walls, flickering candlelight, and a room filled with gears spinning fast enough to make your stomach turn. Honestly, if this place had a Yelp review, it'd be 1 star for comfort, 5 stars for weirdness. But we're not here for luxury. We're here to watch a beam of light try, and almost fail, to make it across the room. Before we begin tonight's journey of discovery, I just have a small favor to ask. If you're enjoying this peaceful little corner of science, feel free to hit the like button or subscribe so you won't miss any of our upcoming nighttime explorations. It really helps this small channel grow, and it means a lot to me. If you're still awake enough to type a few words, I'd love to know, where in the world are you listening from? And what time is it where you are right now? There's something so lovely about seeing science quietly stretch across time zones, shared together in stillness. I truly hope this story is gentle enough to help you drift off to sleep, but there's always a small risk. It might be too interesting, and if you do stay awake through the whole thing, at least you'll walk away with a bit of new knowledge. And honestly, that's not a bad reason to lose a little sleep. Now, take a deep breath in and slowly exhale. Let's begin. The basement is colder than you expect. The air smells faintly of soot and oil, like something halfway between a chapel and a workshop. You take a careful step down the stone stairs, one hand grazing the wall to keep your balance. Down here, time feels thick, as if the room has stored all its past moments in the dampness of the walls. There's a table ahead. On it, a simple candle burns, held steady in an iron stand. Its flame wavers in the stale air, casting elongated shadows that jump and ripple with every tiny movement you make. Next to it stands a large, peculiar contraption, at least 5 feet tall, with a vertical wooden wheel riddled with evenly spaced notches, like the edge of a giant cog. You don't know what it is yet, but it hums with potential. A man adjusts something near the base of the machine. His sleeves are rolled up, and there's soot smudged across his forehead. His name is Hippolyte Fizeau, and he's just about to try the unthinkable. Measure the speed of something no one's ever successfully timed before: light. Up until this point in history, people believed light either traveled infinitely fast, or so fast it might as well be. Newton thought it moved like particles. Huygens said it behaved like waves. But none of them could prove how fast it actually went. That's where Fizeau comes in. You move closer. The candlelight dances across his notes, rows of precise numbers and diagrams drawn in crisp ink. His eyes flick toward you, but he doesn't seem surprised you're here. After all, you're just here to watch. He places a mirror at the far end of the room, maybe 8 meters away. Then another mirror, angled just so, along the return path. And finally, he positions the notched wheel between the candle and the first mirror. The setup is surprisingly minimal, almost homemade. But that's the point. You crouch near the wheel and peek through a small slit behind it. Through that narrow view, you can see the candle flame on the other side. But there's something strange about the view. The light flickers, then blinks out entirely, depending on how fast the wheel spins. At just the right speed, the returning light from the mirror won't pass through the next notch. Instead, it hits the edge, the solid part, and vanishes from sight. Fizeau turns a crank. The wheel begins to rotate. Slowly at first, then faster. The The hum rises to a buzz. You feel it in your chest before you hear it in your ears. A flicker, then nothing. The flame vanishes, snuffed out by motion. Not real motion, but timing. The light didn't disappear. It was merely blocked, delayed, just long enough to miss its narrow window of return. You blink. The light comes back, then vanishes again. It feels like a magic trick, except it isn't magic. It's measurement. You realize that this flickering isn't random. It's the result of perfect alignment between the light beam and the rotating wheel. Fizo scribbles something in his notebook, numbers, equations, something about angles and distances. You can't keep up, but you understand the heart of it. Light goes out, light comes back, unless the wheel interrupts it. If you know how fast the wheel spins and how far the light has to travel, you can figure out how fast the light is moving. You shift your weight and glance at the candle again. Its flame is still dancing, still feeding the experiment with photons. It's astonishing how much hinges on something so ordinary. A wax cylinder, a piece of string, a flame. Scientists still debate whether this was the most accurate way to do it, or just the most clever. But one thing is certain, it worked. You lean back against the stone wall, arms crossed. In this moment, you're not watching an experiment. You're watching time stretch and fold, watching cause and effect play tag across the room, watching light, something you always thought of as instant, take its sweet, finite time to get where it's going. And suddenly, time doesn't feel so solid anymore. It feels like something alive, something playful, and somewhere deep in your chest, you feel the quiet thrill of knowing someone, somewhere, lit a candle, spun a wheel, and slowed the universe down just enough for the rest of us to measure it. You linger in the cold stone cellar a little longer, watching the wheel slow to a stop. The candle flickers again, no longer interrupted. The tiny beam now reflects cleanly off the mirror, through the next notch, and directly back into your eye. Just like that. The light is returned to behaving as it always seemed to, instant, obedient, invisible in its journey. But now, you know better. You've seen the flicker. You've felt the delay. Light is fast, yes, but not infinite. The thought sends a quiet thrill down your spine. It makes the room feel warmer, somehow, like a mystery just whispered the answer to you. You step away from the experiment and glance back at the rest of the room. Simple tools, humble candlelight, and a few spinning gears. It feels almost disappointing that something so profound could be uncovered by such plain objects. But maybe that's the magic. The idea that you don't need a telescope the size of a house or a laser built into a satellite to measure the universe. Sometimes, you just need patience and a little cleverness. You take a slow walk up the cellar stairs. The wood creaks beneath your feet. Each step feels like you're leaving behind something important. But don't worry, it's coming with you. Because now, we go backward, back further, before the spinning wheel, before the mirrors, even before Fizeau. We're going to visit the questions themselves, the ones that first made people wonder if light really traveled at all. You're in ancient Greece now. The air smells dry and chalky. You're surrounded by marble pillars and philosophers with beards longer than your patience. One of them, Empedocles, is pacing back and forth, making wild gestures at the sky. He's convinced that light is something real, something that moves from one place to another, not just an instant magical effect. His peers think he's being dramatic. After all, when you strike a flint, the spark appears immediately. When the sun rises, the light is already there. So, why assume it has to move at all? You sit quietly on a stone bench, watching them argue. Some of them believe your eyes send out beams to feel what's around you. Others think the objects themselves radiate visible essence. No one's entirely sure, but no one thinks to test it either. Science, at this point, is more about ideas than evidence. Time slides forward, and now you're in the Middle Ages, flickering torches, heavy robes, lots of Latin. A man named Alhazen is scribbling notes by lamplight, trying to explain vision using geometry. He argues that light bounces off objects and into the eye, not the other way around. He even starts to imagine the concept of speed, that maybe light, like sound, has a delay. But without tools to measure it, the idea stays just that, an idea. You drift through centuries, past Newton, who throws in his 2 cents by declaring light is made of particles, past Huygens, who claps back with the wave theory. The debate gets louder, but no one builds a machine. The question remains suspended in thought. Then something changes. It's the 1600s now, and you're standing on the deck of a ship. The sails billow, the sea sparkles. You're with Ole Romer, a Danish astronomer who isn't measuring light with wheels or candles, but with Jupiter's moons. Yes, you heard that right, moons. He's been watching them eclipse behind Jupiter for months, carefully charting their timing. And something odd keeps happening. When Earth moves away from Jupiter in its orbit, the eclipses happen a little later than expected. When Earth moves closer, they happen earlier. You lean against the ship's rail, squinting at the telescope he's using. He doesn't see light as instant anymore. He starts to realize maybe the light from those distant moons takes time to reach Earth. Maybe the delay isn't in the moons, but in the beam. Römer does something no one else has managed. He estimates how long light takes to travel a known distance, specifically the extra distance Earth travels in its orbit. His numbers aren't exact by modern standards, but they're breathtakingly close. You feel a twinge of amazement. He didn't need lasers or rotating gears, just a telescope, a notebook, and the patience to watch moons blink. You drift away from the sea and back onto solid ground. Centuries spin forward again, landing you at Fizeau's doorstep. You realize now that his flickering wheel wasn't just a clever trick. It was the physical echo of centuries of curiosity. It was the first time light speed was tested on Earth, with tools you could carry. Still, you wonder, why did it take so long? Why didn't more people try this sooner? And the answer, perhaps, is more emotional than scientific. People assumed light was perfect, divine, above measurement. You don't time the divine, you revere it. But someone like Fizeau wasn't content with reverence. He wanted numbers, proof. And so, he built his wheel. As you wander further through time, you notice something strange about the world of early science. It's full of assumptions. Assumptions that things are instant, that nature behaves the way we expect, and time and again. Those assumptions crumble. Scientists still debate whether the early theories of light were more imaginative or more misguided. But in those contradictions, science found its rhythm. You smile slightly as you walk under a flickering street lamp, thinking how wild it is that something as humble as a candle and a spinning wheel could settle a debate stretching back thousands of years. You wonder what other questions are waiting, what other mysteries are just one clever machine away from becoming clear. The wind rustles through your coat. The stars above don't flicker. They shine steadily. But now, you know even their light takes time. Some of it began its journey before you were born, some before Fizzo was born. And yet, it still finds its way to your eyes. You pause and look up, imagining a photon hitting your retina, a particle, a wave, a messenger from the past. It traveled all this way, waited all this time, just to tell you, I was never instant. I was always arriving. You keep your eyes on the stars as you walk, their silent glow following you like quiet observers. It's hard to unsee what you now know, that even the fastest thing in the universe takes its time. And yet, your brain never noticed. It stitched reality together so seamlessly that you never thought to question how long the stitching took, until someone like Fizzo held up a mirror, literally, and forced us to look closer. The air around you softens as your surroundings begin to shift again. The stars fade, the ground settles, and you find yourself standing in a workshop filled with the scent of fresh wood and oil. The wheel is here again, bigger this time. There are more mirrors now, more candles, and more diagrams scattered across a wide wooden table. You run your hand across the surface, careful not to smudge the ink. The papers are covered in math, yes, but also in sketches, little spirals and arcs that hint at something much more complicated than a spinning gear. You look up, and there it is, a machine taller than you, with a wheel that has hundreds of tiny notches cut around its edge. You recognize the setup from before, but now the air feels different. There's tension here, nervous excitement. This isn't a thought experiment anymore. It's a stopwatch, a machine designed to catch light in the act. You crouch beside the wheel, watching it turn slowly. One rotation, then another. It's not just about motion, it's about timing. You blink, and when you open your eyes again, the speed has increased. The notches blur together. You're watching the edge of motion itself. Now, imagine this. The beam of light leaves the candle, passes through one of those notches, hits a mirror down the corridor, reflects back, only to find that the notch has moved, just slightly, just enough. The returning beam doesn't slip through cleanly. It hits the edge of the gear and disappears. It's a strange kind of silence, the moment light fails to come back. You don't hear anything. There's no puff of smoke, no burst of energy, just absence. But in that absence is everything. The notch missed the light, or maybe the light missed the notch. Either way, you now have a delay, a gap, a moment small enough to measure something once thought immeasurable. You hear Fizzo's voice, softly explaining how it all works, not to you directly, but to the notes in his head. He calculates the distance the light travels, roughly 8 kilometers round trip. He knows the speed at which the wheel is turning. He measures the exact frequency at which the light vanishes. And from that, remarkably, he determines the speed of light itself. You whisper the number to yourself, around 313,000 kilometers per second. Not perfect, but staggeringly close. Closer than anyone has ever come using earthbound instruments. You find yourself smiling. It's hard not to. He did it, with gears and mirrors and firelight. But it didn't stop there. The room begins to shift again, the walls sliding away like theater curtains, and now you're walking through a narrow laboratory filled with glass and metal. Coils of wire hang from the ceiling, and on a workbench near the far end, another machine waits. Not a wheel this time, but a mirror. Small, circular, mounted on an axle. You recognize the name already forming in your mind, Léon Foucault. You remember how he improved on Fizzo's method, not by rejecting it, but by asking a new question. Instead of using a rotating gear to block light, what if you used a rotating mirror to shift it? You move closer to the table. The setup is elegant. A beam of light bounces off the mirror, travels across the room, reflects off a distant stationary mirror, and returns. But in the time it takes to go and come back, the first mirror has turned ever so slightly, just enough to nudge the returning beam in a different direction. You kneel and peer into the detector at the end of the path. At first, the beam lands where you expect, but then Foucault starts spinning the mirror, slowly, then faster, and now the beam moves, not wildly, but just enough to notice, just enough to measure. This time, there's no vanishing act, no flickering out of existence. Just a subtle shift, a tilt, a motion that shouldn't be there unless the beam took time to return. It's a different kind of elegance. Where Fizeau made light disappear, Foucault made it slide. One experiment cuts, the other dances, but both are built around the same idea. Light isn't instant. It moves, it travels, and if you're clever enough, patient enough, you can catch it in motion. You stand in awe of the simplicity. The mirror didn't even need to move that fast. A few hundred revolutions per second were enough. Light did the rest, or more precisely, the delay between leaving and returning did. You gently run a finger along the edge of the table. There are still ink smudges here. The smell of candle wax lingers faintly in the room, like a nod to the experiment that came before. You start to realize something. Foucault didn't just improve the method, he proved something even more precise, that light moves slower in water than in air, a direct confirmation of wave theory, a blow to Newton's particle idea, and a victory for clarity. Scientists still debate whether these classic experiments matter in an age of lasers and satellites. But, in truth, they weren't just about measuring speed. They were about changing our expectations of nature. You walk toward the door at the back of the lab. Beyond it, the future waits. A world where C becomes a symbol, not just a speed. A world where knowing the speed of light means knowing the structure of time itself. But for now, you pause in the doorway, taking one last look at the mirror. It doesn't look like much, but it turned the world, just a little. You smile again, not out of pride, but out of comfort. Because even in the vastness of space and time, sometimes all it takes to learn something new is to watch a reflection move. You step through the doorway and into the cool hush of open air. The lab disappears behind you, leaving only a soft breeze and the sound of distant bells. Your feet find cobblestones, uneven but familiar, like the rhythm of old thoughts resurfacing. The city around you, Paris, still glowing with gaslight, is quiet. And yet, above the hush, something has changed. You feel it not in your ears, but in the pacing of the world itself. It's as if everything is now ever so slightly delayed, not broken, just gently revealed. You glance up at the sky again, and the stars no longer look immediate. They look patient. You can almost picture each ray of light as a traveler, setting out from its distant origin long before you were born, arriving now with quiet footsteps at your waiting eyes. But you're not staying in the city tonight. You're traveling again, this time, far beyond mirrors and wheels and even telescopes. You're heading into equations, into constants, into the heart of one of the most profound ideas modern physics has ever embraced, that the speed of light, this number that Fizeau and Foucault nudged into visibility, is not just a measurement, it's a law. The world fades into blackness for a moment, not unpleasant, just suspended. And then you land, gently, in a clean, quiet space. No gears, no soot, just a blackboard, a chalk stub in your hand. A symbol appears in the air, steady and silent. C. You stare at the letter. It's lowercase, humble, simple, but it's holding something enormous. That C stands for the speed of light in a vacuum, roughly 209,792 kilometers per second. No need for candles now. This number has been burned into the universe itself. And it's not just fast, it's final. It's the limit, the ultimate speed limit of nature. You start to understand the strange gravity of it. Everything, time, space, energy, matter, has to play by C's rules. It's not just how fast light moves, it's how fast anything can move. Faster than that, you may as well try to outrun your own shadow. You reach out and tap the symbol, and suddenly you're surrounded by movement, particles zipping around you, bouncing and colliding. Time speeds up, then slows down, then warps sideways. You realize that the closer something gets to C, the weirder everything becomes. Distances shrink, clocks tick more slowly, objects gain mass. It's as if the universe resists you when you try to push too close to the edge. This isn't just theory. You see it unfold around you. A spaceship accelerates in the distance. You float beside it, watching. As it approaches light speed, it begins to stretch, not physically, but temporally. Time inside the ship slows relative to the outside world. Days pass within it, but years pass outside. You could leave Earth for a coffee break and come back to find everyone you knew has aged decades. You drift backward again, to a place where all this first started to make sense. A small patent office in Bern, 1905. There's a desk. A young man with wild hair is scribbling feverishly in the margins of technical documents. His name is Albert, and he's about to do something no one expects from a guy who stamps applications all day. Rewrite how we understand time itself. You sit across from him, quiet as a breeze. He doesn't look up, too busy rearranging space and time in his mind. He's working on something called special relativity, a theory built around a single idea. C is constant. No matter where you are or how fast you move, the speed of light remains the same. It never changes. Everything else does. You watch him pause and lean back. The room is silent. He's just written the phrase that will define a century. ERMC2. It's elegant, compact, but it hides a thunderclap. Energy and mass are the same, just different states. And the conversion between them, it runs through C2, the square of the speed of light. That little number, born from flickering candles and spinning wheels, now unlocks the secret of the stars. It tells you how the sun burns, how atoms split, how galaxies breathe. You close your eyes for a moment. The weight of it is not overwhelming. It's soothing, as if someone finally told you the rules of a game you've been playing all your life without knowing. Scientists still debate whether the universe had to be this way, or if C is just one version of what's possible. But here, in this world we're in, it's not optional. It defines everything. You walk to the window of the patent office. Outside, the 20th century is beginning to stir. Theories will grow. Technologies will bloom. People will try to push past limits, but the speed of light will remain, gently and firmly, the boundary no one can cross. You step out into the street, and it's not the same world you entered. Every beam of light you now see, every glow, Every shimmer, every faint twinkle from a faraway star is part of the same quiet rule book, not instant, not infinite, just wonderfully, unshakably fast. And more than that, it's the framework for everything else. Time itself isn't separate from space anymore. They're woven together like two threads of the same fabric. When you stretch one, you stretch the other, move faster, and time flows differently. Fall into a gravity well, and light bends. The universe is elastic, but it never tears. It just curves, quietly, patiently. You run your hand through the air as you walk. You can't feel it, but you know it's true. Photons are passing through you every second, silent messengers of distant origins. Some of them started their journey from stars that no longer exist, but their light is still here, still arriving. You reach a bench under a flickering lamp and sit down. You don't need a blackboard now. You don't need equations or spinning wheels. You just need this moment, the calm awareness that even the fastest thing in the universe moves one heartbeat at a time, that even light, in all its brilliance, obeys the same rhythm you do, forward, gently, always forward. You rest there on the bench, your fingers tracing slow circles on the worn wood beneath you. Around you, the quiet world of the early 20th century glows faintly under gas lamps and drifting smoke. But in your mind, you're far beyond it now. You're no longer just a witness to the measurement of light's speed. You're beginning to feel its consequences ripple outward, into time, into gravity, into the very shape of reality. You close your eyes. The lamp above you hums softly. When you open them again, the world has shifted once more. You're still sitting, but the air feels heavier now, thicker somehow, like the quiet just before a thunderstorm. The sky above is dark and silent, but this is no ordinary night. You're no longer in a city. You're inside a gravitational well. Beneath your feet lies a massive object, too massive to see, too dense to understand at a glance. But you feel it pulling, not painfully, not suddenly, just gently, constantly. Like a lullaby, you can't quite hear but still respond to. You're near a black hole, not close enough to fall in. Don't worry, you're far enough away to be safe, but close enough to witness something astonishing, something light itself struggles to explain. You stand slowly, and the moment you do, you see it, a distant star's light bending, not a curve like a rainbow or a beam through glass. It's more like a soft warping of space itself. The light doesn't travel in a straight line anymore. It follows the shape of gravity. You watch in stillness as photons, normally so sure of their path, curve gently around the massive object before you. It's not because they want to. It's because they have no choice. Space itself is no longer flat here. It's stretched, like fabric drawn downward by something immensely heavy. And light, being light, simply follows the curves. You begin to walk again, slowly now, as if time itself were thicker near this gravity. Your footsteps take on a dreamlike rhythm. With each step, you remember, light doesn't just mark time, it experiences it differently depending on the terrain. If you were closer to the black hole, time would pass more slowly for you than for someone farther away. Not metaphorically, literally. You think about your watch. If it were ticking now, it would still tick at the same pace, for you, but to someone far from this place, your seconds would stretch, your movements would appear slowed. Not because you're lagging, because the shape of space and time itself has changed. You place a hand over your chest, feeling your own heartbeat. It's steady, familiar. But now you know, this rhythm exists within a context that bends and warps depending on where you are in the universe. Even your pulse is woven into the shape of space. Scientists still debate whether gravity is a force pulling objects together, or simply the result of objects telling space how to curve. But here, where the light bends and time drags, the distinction almost doesn't matter. You feel the curvature more than you understand it. And somehow, that's enough. The ground beneath you shifts, not violently, just subtly. And now, you're standing not at the edge of a black hole, but beside a massive observatory. Tall metal scaffolding surrounds a telescope so large it looks like it could swallow the sky. You're on Earth again, specifically the early 20th century, and something important is about to happen. A man adjusts the scope with gloved hands, his breath misting in the cold morning air. He's waiting for an eclipse, not to watch it, but to prove a theory born from Einstein's mind not long ago. Predicting that gravity would bend starlight, this man, Arthur Eddington, has sailed to an island to catch the moment when the sun passes in front of certain stars. If Einstein is right, those stars will appear slightly shifted from where they should be. You step beside him and look through the scope. At first, nothing, just dark sky. But then, there it is, a star, just next to the sun, visible only because the moon has covered the solar glare, and it's in the wrong place. Not dramatically, just off, barely enough to notice, unless you're looking for it, unless you're measuring the path of light through bent space. You hold your breath. The star is proof. The prediction was right. Light doesn't just travel, it responds to gravity, to curvature, to context. The results of this experiment will soon ripple across the world. Einstein's fame will explode. The idea that gravity affects the path of light will become part of our basic understanding of the cosmos. But here, in this still moment, it's just you and a telescope and a light beam obeying the shape of something invisible. You walk away slowly, leaving the observatory behind, and find yourself drifting again, not through space this time, but through thought. You remember the candle, the wheel, the shifting mirror. Now, all of it feels like the first chapter of something much deeper. We weren't just trying to catch light. We were trying to understand its language. You pause on a hilltop now. Above you, the night sky is clear and endless. You look up, and you no longer see dots of light. You see motion, distance, delay. You imagine the photons reaching you, some of them bent, some red-shifted from distant galaxies, some caught briefly by gravity before resuming their journey. You imagine being light, setting out from the heart of a star, skimming past planets, dodging dust, weaving through magnetic fields, maybe even being caught for a moment by a telescope lens, then freed again, all without pause, no rest, just movement. And yet, from light's perspective, if it had one, it experiences no time at all, no journey, no delay. It simply is. From the moment it leaves to the moment it arrives, it exists in a single instant. The space in between, that's for us, for everything bound by clocks and calendars. You take a long breath. The breeze on the hill is cool. You sit down, legs folded, hands resting on your knees. Around you, light continues to fall, softly, steadily. And now you understand. Even the straightest beam of light carries within it the memory of curves. You stay seated on the hilltop for a while, knees tucked in, wrapped in the quiet hum of the universe. The breeze curls around you gently, as if even the wind is slowed by the weight of what you now understand. Light isn't just brightness, it's memory, it's motion. It's a thread stretched across time and bent by gravity's invisible fingers. You tilt your head slightly, watching the stars, and somewhere in that soft silence, a new question begins to stir. If light moves at a constant speed through the vacuum of space, what happens when it isn't in a vacuum? The thought pulls you forward, quite literally, into a new space, a quiet laboratory with high windows and polished glass. The shelves are lined with containers of strange materials: quartz, water, plastic, thick oils, cloudy gels. This isn't a place for black holes or galaxies. It's for something more subtle, more earthly. You walk slowly between the table until you find it, a beam of light split in two by a triangular prism. On one side, the beam moves through air. On the other, it passes through a chunk of crystal-clear glass. Both exit the other side, but something's different. The glass beam lags ever so slightly behind. You lean in closer, blinking slowly. It's real. The beam that passed through the solid material has been slowed down, not stopped, not damaged, just delayed. Not because it was tired or confused or polite, but because the particles within the glass kept interrupting its flow. You imagine the photon as a tiny traveler moving along a perfectly straight path until, bonk, it hits an atom, gets absorbed, then re-emitted, and again, like a child trying to sprint through a crowded hallway, constantly bumped and jostled by a sea of elbows and book bags. That's what happens to light and materials. It's not truly slower in the purest sense. Between interruptions, it still moves at sea, but the journey takes longer. The more atoms in the way, the more delays. The denser the material, the more sluggish the beam becomes. In diamond, for instance, light can slow to just over 120,000 kilometers per second. In certain cold, dense gases, it can slow to nearly a crawl. You touch the side of the prism, feeling its cold surface beneath your fingertips. Inside this glass, light is experiencing something completely different from the open air. Not by choice, by circumstance. It's another reminder that the environment shapes the journey. Scientists still debate whether what we call slowing is even the right word for it. Is the light actually traveling slower? Or are we just seeing the effect of countless tiny interruptions stitched together? The answer, frustratingly and beautifully, is both. You walk over to another part of the lab, where someone has prepared a vat of thick syrup. The light shining through it is golden, viscous looking. You bend down and peer sideways at it. It's almost poetic. The idea that light, which seems so intangible, could struggle to make its way through something so simple, like molasses through mesh. But this isn't just about syrup or glass or optics textbooks. This is about how light, our swift, constant friend, can become sluggish depending on where it is. Context matters, and not just in materials. In biology, too. You blink, and now the lab has changed again. There are microscopes everywhere, and the air smells faintly of plants and metal. You're surrounded by glass dishes, each one holding a different tissue sample: nerve cells, retinas, photoreceptors, all designed to detect and interpret light. And suddenly, light isn't just a thing that travels. It's a thing that triggers. You watch as a beam enters the eye of a preserved specimen, and the cells react, firing electrical signals down a chain, like falling dominoes. The delay here isn't just because of atoms, it's because of interpretation. The body doesn't just receive light, it decodes it, and that takes time. You peer into one of the microscopes and watch as photons strike the back of a retina. Chemical changes occur, molecules shift, proteins dance, and eventually, maybe 100 milliseconds later, your brain goes, "Oh, that's red." It's not instant, not even close, but it feels that way because your brain has gotten very good at pretending light moves faster than it does. It patches the delay with assumptions. It fills the gaps. It tells you you're seeing the world in real time, even when you're not. You pull back from the microscope and exhale slowly. Even within you, light is delayed, not just by glass, not just by stars, but by nerves and cells and perception. The journey of a photon doesn't end when it reaches your eyes. It ends only when your brain has had a word with it. And sometimes, it never even gets that far. You pass another table with a sample of melanin, the pigment in your skin and eyes. You watch as light hits it and is absorbed entirely. No bounce, no signal, just a silent end. Some light doesn't get to be seen. Some light just stops. You look down at your own hand under the lab lights. The skin absorbs some of it, reflects the rest. You're seeing what's left over, the rejected light. It's strange, in a comforting way. You're made of the same materials that slow and bend and even end light's journey. You're not separate from the story. You're part of it. In one final corner of the room, a tank of water bubbles quietly. A laser beam cuts through it, refracted and redirected. You trace its path with your eyes, following the way it bends when it enters the water, then bends again when it leaves. That bending isn't because the light wants to change direction, it's because its speed changes, slower in water, faster in air, and the shift pulls it off course, like a runner switching from sand to pavement mid-stride. You sit beside the tank, resting your hand on the smooth edge. You think about all the places light can be, in diamonds, in rain, in eyes, in oceans, and in each of those, it moves differently. It adapts, it yields, it continues, and for the first time, it really sinks in. Speed isn't everything. What matters is how far something gets, and what it becomes along the way. You remain by the tank for a while, watching the laser beam ripple softly through the water. The beam isn't bright, it's muted, gentle, like a whisper of light rather than a shout. And still, it moves with purpose, bent, delayed, refracted, but undeterred. It makes you wonder, if light can slow down when it enters something dense, can it ever speed up? The question feels ridiculous at first. After all, you've been walking with this story long enough now to know that nothing exceeds the speed of light in a vacuum. It's the cosmic speed limit, the finish line no one's allowed to cross. But then again, science loves loopholes, and you're about to find one. The lab dims and folds away, and you find yourself stepping into a space far stranger than any you've visited so far. The floor beneath you vanishes, not falling away, just ceasing to be. You're now surrounded by translucent panels and faint humming sounds. It feels like stepping into a thought experiment made real. In front of you, scientists are arranging a peculiar setup, a vapor of cooled atoms, slowed to near absolute zero, suspended inside a magnetic trap, and through this chilled fog, a pulse of light is about to travel. You stand back as the beam is fired. It enters the fog, and something astonishing happens. It slows. not just by a little, not just to the speed of sound. It slows to the speed of a bicycle, then a walking pace. Then it stops. You blink, stunned. The pulse, the actual wavefront of light, has been effectively frozen. It's not just being delayed by bouncing around. It has, for all practical purposes, been brought to a halt. Inside the ultra-cold vapor, the photons no longer move forward. They're stuck in place, trapped in a moment, like insects in amber. And yet, the story gets stranger. The researchers turn off the trap, the fog evaporates, and the light pulse starts moving again. As if nothing had happened, as if time had paused for it, and now simply resumed. You walk slowly around the edges of the chamber, trying to grasp what you've just seen. Light, this ultimate symbol of motion, can be frozen and revived without being destroyed, not by breaking the laws of physics, but by learning how to press gently on their edges. You recall what you've learned so far. In glass, light slows because it's interrupted. In fogs like this, it slows because its entire form gets imprinted into the medium, its information stored temporarily in the arrangement of atoms. And then, when released, it picks up right where it left off. Scientists still debate whether light stops in a classical sense, or whether its energy simply transforms temporarily. But either way, what you're witnessing is real, and it opens a curious possibility. If light can stop, in a way, can it go faster than its own limit? You hesitate. The rules are clear. Nothing can move faster than light in a vacuum. But that's the catch. In a vacuum. In other materials, where light slows down, strange things can happen. You're pulled now to another part of the chamber, a different experiment. This one uses a slab of specially engineered material, a metamaterial, designed not by chance, but by intent. Its internal structure is so precise, so finely tuned, that it plays a trick on light itself. They shine a pulse through it. You lean in close, watching. The pulse enters the material and exits the other side seemingly before it should have. Not in a magical way, not in violation of causality, but in a way that suggests the peak of the wave, the leading edge, traveled faster than it normally would. You feel the question surfacing again. Is that even possible? The answer is thorny. Physicists call it superluminal group velocity. It doesn't mean information travel faster than light. It means the shape of the wave, the pattern of peaks and troughs, moved ahead, like a shadow cast faster than the object creating it. The light didn't break the rules. It bent around them. You drift away from the experiment, your thoughts moving faster than your feet. It's dizzying to realize how much of our understanding of speed is conditional. What you thought was a hard ceiling turns out to be a landscape full of strange terrain. In one corner of your mind, you're still imagining that frozen light, stuck mid-pulse, as if caught holding its breath. And in another, you're imagining the pulse that exited before it should have, like a messenger arriving before the message. Both are true, both are real, and neither breaks the cosmic limit. They just reframe it. You begin to understand. Speed isn't just about motion. It's about communication. It's about how fast something can carry meaning from one place to another. And as long as that meaning stays within the rules, the behavior of light can be startlingly strange without ever being illegal. You return, finally, to a quiet hallway where the walls are lined with panels of fiber optics. Long, glowing threads snake along the baseboards and ceilings, modern highways of information. You walk beside them, listening to the soft hum of laser pulses zipping through glass at 2/3 the speed of light in a vacuum. These aren't ancient candle beams or experiments with syrup. These are the veins of the digital world. Billions of pulses every second. Banking data, phone calls, love letters, all of it traveling at light speed. Well, almost, and still, with every message that arrives, a delay, tiny, minuscule, but real. You pause at a terminal where a technician is monitoring packet latency between continents. You watch the graphs dance across the screen. Even in this age, with satellites and underwater cables and near-instant communication, we're still waiting on light, always waiting, and somehow, that's comforting. Even in a world built for speed, even in a system that runs on urgency, there's always that tiniest of pauses, that invisible breath between emission and arrival, that flicker of time where the light is still on its way. You smile to yourself. It's the same delay Fizeau caught with a wheel, the same hesitation Foucault tracked with a mirror, the same blink Romer saw from across the solar system. We've dressed it up in wires and lasers and equations, but it's still there. And no matter how fast we get, we will always be just a little bit behind the light. You walk slowly down the hallway lined with glowing threads of light, letting your fingers hover just above them. The fibers hum faintly beneath their sheaths, carrying secrets across oceans and under cities, across time zones and into hands that will never know how far the messages have traveled or how delicately. But now you do. You know about the candles and the wheels and the black holes and the frozen fog. You know that every message, every flicker, is part of a long, strange history. And just when you think it's all been discovered, the story nudges you again. You're led now into a smaller room, warm and dark, lit only by a soft blue glow. The walls pulse gently with movement. At first, it feels like you're inside some kind of futuristic observatory. But then you see them, dozens of tiny screens, each displaying a single word or phrase, words that float, stutter, disappear, and beside each screen, a corresponding signal, just a spike of voltage traveling along a path of light. You realize this is an experiment in information, not just light as illumination, but light as language, as code, as memory. You sit down beside a young researcher typing rapidly into a console. She's explaining to someone, not to you, just out loud. The way people talk when they're excited and don't care who's listening. How the light pulses are encoded, each one a burst of meaning, not a color or an image, but a decision. On, off, this, that. She's working on a way to optimize communication. How to move information with fewer photons, less energy, better clarity. You lean closer and realize something fascinating. These pulses, these flickers in the fiber, each one carries just enough light to be detected, no more, no less. In some cases, they ride on single photons, one photon per bit, one particle of light per thought. You let that sink in. A single particle, born from a laser, split and aimed, can carry an instruction, an emotion, a piece of someone's voice, or a digital memory of their face. And just like that, the history of light shifts again, not just as a wave, or a beam, or a cosmic messenger, but as a vessel for thought. You're pulled deeper into this idea now. The walls of the lab dissolve, and you find yourself drifting through a series of small vignettes. A miner switches on a headlamp deep beneath the Earth's crust. A tiny beam cuts through centuries of rock, showing the path forward. A satellite blinks down a sequence of laser pulses across the vacuum of space, syncing time between continents. A lighthouse sends rhythmic bursts out over a black sea, letting sailors know land is near. A firefly pulses in a silent forest, its glow a tiny flare of intention. And you, holding a screen in your hand, scrolling through messages that are, at their core, just tiny bursts of light, interpreted, filtered, and delivered to your eyes. Light is no longer just about speed, it's about meaning and motion. You find yourself standing now in front of a strange-looking device. It's a box, no bigger than a microwave, humming quietly. The label on the side reads, Quantum Key Distributor. You don't need to know the circuitry to know what it's doing. This machine uses single photons to create encryption keys, completely secure, because any attempt to observe the photons would change them. You watch as a beam splits into two paths. One heads to the sender, one to the receiver. Both paths are fragile, sensitive. The particles themselves are the message and the messenger, the envelope and the ink. Scientists still debate whether this will replace modern encryption or simply augment it. But for now, it stands as proof that even uncertainty can be useful. Even quantum strangeness can be harnessed to protect information rather than threaten it. You step back and look at the whole system. It's bizarrely poetic. We used to measure light by how fast it traveled. Now we use it to guard secrets. We used to think of it as a constant. Now we know it can be split, entangled, altered, without ever breaking. And still, the photons obey the same rules. They carry, they delay, they bend, but they never break. You move again into a room with mirrors, hundreds of them, angled and polished and glowing faintly with embedded lasers. At first, it feels like a fun house, until you realize you're inside a prototype of an optical computer. No electrons here, just light. Each calculation is performed not by electric current, but by paths of laser beams, intersecting at tiny gates. You watch as a calculation unfolds. A laser splits, reflects, cancels out in one direction, amplifies in another, and the result, a simple number, appears on a screen. But no wires buzz, no transistors click. It's silent, just photons, doing math. You bend closer to the glass and feel a small awe bloom in your chest. This isn't the future, this is now. And it all began with a candle, with someone asking, "Is light instantaneous?" And someone else saying, "Let's find out. Now we're here." Whispering thoughts between continents using invisible beams, encrypting bank transfers using uncertainty, building logic gates out of nothing but reflected pulses. And yet, it's all still light, the same light that escaped stars, the same light that curved around gravity wells, the same light that hesitated through syrup. You walk slowly through the mirrored maze, the lasers parting around you like streams of red silk. You think about how we once feared the dark, not because it was dangerous, but because it meant light had left us. Now, we carry it in our pockets. We bounce it off satellites. We encode our memories in its flicker, and still, we measure, still. We wait for the return beam. You reach the final panel of the optical computer and place your palm on its surface. Warm, just slightly. Light has passed through it, carried meaning, done work, told the machine what to do. And now it rests, waiting for the next pulse. You realize something you hadn't thought before. Light doesn't just move, it serves, quietly, tirelessly. Whether helping plants grow or relaying a whispered message across the globe, It exists to be received, and in that gentle purpose, there's something beautifully humble. It doesn't demand attention, it simply arrives. You leave the mirrored room with a kind of reverence, as if stepping out of a cathedral built not of stone, but of photons. Behind you, the lasers still hum, steadily, dutifully, like monks in silent prayer, calculating and communicating with nothing but light and angles. You feel lighter now, not just because of where you've been, but because of what's beginning to settle in your bones. That light, for all its speed and strangeness, is also deeply dependable. You walk into open air again. This time, the world around you feels familiar, modern, even. Cars glide by, streetlights glow, screens flicker in windows. But you no longer see these things as objects. You see them as expressions of light's cooperation. Light doing what it's always done, illuminating, guiding, translating, traveling. You turn a corner and enter a quiet little museum, not a grand one, but the kind tucked between bookstores and cafes, where time moves slowly and the floorboards creak with every step. There's no crowd here, just soft light, glass cases, and artifacts that hum with quiet meaning. One display catches your attention. It's small, simple, a charred stump of a candle. Next to it, a gear, one of Fizo's original wheels, or at least a replica. There's a mirror beside it, slightly tarnished, tilted to reflect your own face. You pause and smile. It's strange how far we've come from such humble beginnings, and stranger still, how little we've truly left them behind. You lean in to read the placard. It talks about the experiment you now know by heart, the beam of light, the spin of the wheel, the flicker that told us. Light moves, it travels, and if we're careful, patient, curious, we can measure its journey. Scientists still debate whether Fizo realized how iconic that moment would become. But maybe that's the point. Discovery rarely feels grand in the moment. Often, it's just a question, a piece of equipment, and someone who refuses to look away. You move on. The next case holds an early fiber optic cable, delicate, hair thin, looped like a sleeping snake. The glass is slightly yellowed, but you can still see where the light once traveled. The caption talks about how it transformed communication, how it took light from something we used to observe and made it something we could use. You step back and take in the room. All around you, artifacts whisper, lanterns, lenses, prisms, antennas, every one of them a turning point, every one of them a moment where light changed what was possible. And then, at the far end of the room, something unexpected, a simple chair, placed in front of a screen playing a looped video. You sit down, and the screen flickers to life. No narration, just images, light across water, light through stained glass, light reflecting off a butterfly's wing, light bended through rain, curling around skyscrapers, glancing off the moon. You watch, and something softens in you. It's easy to think of light as a tool, a system, a wave function, but it's also beauty, its color, shape, contrast. Without it, the world would still exist, but you wouldn't know it. And perhaps more than anything, light is how we make sense of where we are. You close your eyes for a moment just to see what happens. And of course, darkness, not frightening, just complete. You listen, you breathe, and then you open your eyes again, and the room reappears, not in sound, not in texture, but in light. You remember, sight is not light itself. It's your brain's reply to light's arrival. A conversation, happening faster than you can comprehend. But what happens when light arrives from far beyond our world? You rise from the chair and walk slowly to the exit, stepping out into darkness again, not the darkness of night, but of space. The stars reappear above you, brighter now, each one a different distance, a different story. You understand that their light is not new, it's ancient. Some of it began its journey before humans walked upright, before Earth had continents, before our sun even had planets. You lie down on your back, on something soft and warm and completely unreal, a memory of grass, maybe, and you let your eyes rest on a single star. From this far away, a photon feels like a miracle. It had to survive eons of space, dodge planets, survive gas clouds, remain unscattered and uninterrupted, just to land here, now, on your retina. It doesn't know what it hit, it just arrived. You wonder how many others didn't make it, how many collided with dust, how many were stretched by the expansion of space, how many simply lost energy and faded into background radiation. And yet, some made it. That's what amazes you most, not the speed of light, but its persistence, its patience. We often think of speed as urgency, as force, but light's speed is more like constancy. It just keeps going. It doesn't rush. It doesn't slow. It moves through everything, through water, through glass, through space, through thought, and it waits for us to notice. You feel that now, a kind of soft gratitude, not just for the stars or the candles or the mirrors, but for the simple fact that something so fundamental can be so gentle. Light could have been chaotic, destructive, but instead, it offers visibility, direction, clarity. It lets us see, and in doing so, it helps us know. You glance down at your hand, faintly lit by starlight. It seems still, solid, but you know now that it's bathed in motion. Thousands of photons land there each second, bounce off your skin, and race away. Some are absorbed, some are reflected, all are changed. You realize you're part of this too, a surface that light touches, a shape that reflects it, a presence that, in some tiny way, shapes the path it travels. You breathe in, you exhale. You don't need to move right now. Light is moving for you. You stay there, lying in the soft quiet, wrapped in the patient embrace of starlight. There's no rush. Light isn't in a hurry, and tonight, neither are you. For a long moment, you just exist, your body motionless, your breath slow, your thoughts carried gently like boats floating along a river of photons. It's peaceful here, but even in stillness, the universe keeps whispering questions. One begins to form, soft and strange. What is light? Really? You followed it across centuries, watched it bend, slow down, disappear, and carry messages. You've seen it act like a wave, like a particle, like both and neither. And yet, the closer you look, the slipperier it becomes. You sit up slowly, blinking in the darkness, and suddenly, you're not under the stars anymore. You're standing in a quiet classroom, chalk dust in the air, faint lines of sunlight slanting through tall windows. The desks are empty. The blackboard stretches across the front wall, covered in tangled diagrams, wiggling lines, sharp spikes, strange loops, arrows pointing in two directions at once. This is where we try to define the indefinable, the nature of light. You walk to the board and peer at the shapes. One looks like a ripple, neat and clean, rising and falling across a flat axis. This is the wave theory of light. It's elegant, predictable, It explains reflection, refraction, diffraction. It describes light as an oscillating electric and magnetic field, dancing together in space. You follow the chalk trail to the next section. The wave dissolves into dots, tiny sparks popping into and out of existence. This is the particle theory. Photons, light not as a continuous wave, but as packets of energy, each with its own momentum and direction. And then, your favorite part, the messy overlap in the middle, the region where wave meets particle. And physics throws up its hands and says, both. Somehow, you trace your fingers along a sketch of the famous double-slit experiment, remembering what you've heard. Fire one photon at a time through a barrier with two slits. And over time, they form an interference pattern, as if they were interfering with themselves, as if they were a wave, but detect them one by one, and they hit like particles, points, little thuds in space. And the moment you try to observe which slit the photon passed through, the interference pattern vanishes. The photon chooses a path. The act of watching changes the outcome. You sit at one of the desks now, resting your chin on your hands. Scientists still debate whether light knows it's being observed, or whether the universe is just inherently fuzzy and doesn't like being pinned down. But either way, the result is clear. Light is not just fast, it's weird. You look up, and the blackboard has changed again. Now it shows a set of equations, Maxwell's equations, beautiful in their symmetry, describing how electric and magnetic fields create each other and propagate through space. These equations predicted light's speed before anyone measured it. They told us light isn't separate from the world. It is the world, a product of the fields that define reality. You turn around, and the classroom melts away. You're back in darkness, deep, deeper than space. This is the world before light. Not just before flashlights or stars, but before the first light. You float there, weightless, in a silent void. No photons, no radiation, just potential. And then, a shimmer. The cosmic microwave background begins to glow. The afterglow of the Big Bang, stretched thin and cool by the expansion of space. You're watching the oldest light in the universe, released when the cosmos was only 380,000 years old. Before that, the universe was too hot, too dense, for light to escape. Photons collided constantly with free electrons, trapped in a kind of fog. But then, just then, the fog cleared. The universe cooled, atoms formed, and light broke free. That light is still here, still traveling, still filling every inch of space, though now so faint it can only be detected by the most sensitive instruments. You reach out and imagine catching one of those ancient photons in your hand, a survivor of 13.8 billion years of motion, and all it's ever done is move. You think about how we mapped this background, turned it into a picture, not because the photons are bright, but because they're even so consistent, so quietly present, that even their tiny temperature differences, fractions of a degree, paint the fingerprints of the infant universe. You drift a little, the image fading, and land softly in a new space. A telescope dome opens above you. You're at a modern observatory now, high on a mountain, where scientists still chase those distant photons. This isn't about stars anymore. It's about exoplanets, galaxies at the edge of visibility, supernovae that blinked out eons ago. You watch as a technician adjusts the lens, eyes locked on a screen where a single speck of light twitches. That twitch will be studied, analyzed, filtered for redshift and gravitational lensing and signal-to-noise ratio. It may be nothing, or it may be something that rewrites everything. And the beauty of it is, no one knows. Not yet. You walk to the edge of the platform, the wind brushing your face, and look up again. This time, the sky doesn't seem like a backdrop. It feels like an archive, a storage vault of light, each photon carrying a timestamp, a location, a memory of where it came from. Some are ancient, some are newborn, but they're all on their way. You take a deep breath and let it out slowly. You've followed light from candle to computer, from retina to radio dish, and somehow, the more you learn, the more mysterious it becomes. Light is wave, light is particle, light is information, light is history, light is time. But it's also this, the thing that lets you see your hand in front of you, the flicker that lets a mother find her child in the dark, the shimmer that bounces off ocean waves and makes you stop walking just to admire it. And maybe that's the most wonderful part. That's something so complex, so debated, so fundamental, can also be beautiful, useful, warm. You remain on the telescope platform for a while, the night stretching quietly around you like a blanket pulled all the way to the edges of the earth. Behind you, the instruments continue collecting light, slowly, carefully, one photon at a time. Out here, there's no noise, just the endless patience of the universe whispering its stories through the faintest of glows. You step away from the railing and begin walking back down the spiral stairs of the observatory, your hand grazing the cold metal railing. Each step feels softer than the last, like gravity itself is loosening its grip, letting your thoughts rise into the air around you. You've seen the past written in light. You've followed its trail across glass and space and time, and now, you're ready to ask something a little stranger. What happens when light stops being something you see and starts becoming something you feel? The air shifts again. The observatory melts away. Now you're standing in a long corridor filled with curves and color. Not like any hallway you've ever seen. The walls seem to glow, though you can't find a single visible source of light. It feels like walking through a dream drawn entirely in soft, shifting hues. And it clicks. You're in a world of infrared. You reach out your hand, and the warmth of your own body creates a faint, ghostly shimmer in the air. You can't see your skin anymore, not with your eyes, but you sense your own presence as heat, infrared light. Just longer in wavelength than what we can see, is constantly radiating off everything warm, your hands, your breath, your thoughts as they buzz through your brain. It's what snakes use to hunt in darkness, what satellites use to monitor forest fires, what remote controls use to change the channel, and here you are, immersed in it, light you can't see, but which touches everything. You walk slowly, and the air thickens again, no longer infrared, but even longer now. Microwaves. They hum softly around you. You don't feel them exactly, but you sense their rhythm. This is the realm of communication. Satellite dishes, cell towers, cosmic background radiation. The universe's afterglow lives here, stretched into this band by the expansion of space. You pass a panel on the wall where tiny microwave antennas are transmitting signals, bits of information you can't hear but know are real. A whisper from a weather satellite, a check-in from a spacecraft halfway to Jupiter, a signal bouncing between continents just to ask, "Can you hear me now?" And just beyond that, another shift, You're now surrounded by radio waves, the longest, slowest members of the light family. They feel almost like a breeze, so vast in their wavelength that they can pass through mountains and buildings and bodies with ease. This is the frequency of music broadcast from towers, of Mars rover updates, of pulsars spinning like cosmic lighthouses, beaming regular radio pulses into the void. You remember the golden record sent with Voyager, inscribed with music and greetings and hopes for peace. A message wrapped in radio, traveling endlessly through space. If someone ever hears it, light will have been the messenger. Scientists still debate whether anyone will ever receive that record, or if it will drift forever, untouched. But even in uncertainty, the act feels meaningful. To send light not as a measurement or a tool, but as a gift. A note slipped into the pocket of the universe, saying, "We were here." You press forward, and the wavelengths begin to shorten again. From radio to microwave to infrared, then up into the visible spectrum, you pass red, orange, yellow. Light becomes something your eyes can interpret again. You feel a strange comfort in this return, as though re-entering a language you know by heart but had temporarily forgotten. Green, blue, violet. And now you're crossing the boundary once more, this time into ultraviolet. You flinch, instinctively. UV isn't gentle. You can't see it, but your skin knows it well. It's sunlight's secret whisper. The thing that warms but also burns. The thing that tells flowers when to bloom, but also gives you sunburn. You're reminded that light, for all its calm grace, carries power. Beyond ultraviolet is X-ray. And suddenly, you're standing inside a radiology lab. You see bones, not just yours, but the ghostly outlines of animals, fossils, even stars. Yes, stars. Because X-rays don't just peer through skin, they also escape from the coronas of distant suns, from the hearts of exploding supernovae, from black holes that tear matter apart. You walk through the room, and the bones fade into brightness. Wavelengths are getting shorter still. You're entering the final domain of the electromagnetic spectrum, gamma rays. Here, light becomes energy, raw, relentless. This is where nuclear reactions occur, where atoms break, where the universe's most violent events leave their fingerprints. Gamma bursts from distant galaxies, particle collisions in high-energy labs, the faint echo of radioactive decay deep in Earth's crust. And then, it all pauses. You're standing in stillness, total quiet, the entire spectrum of light now behind you, like a journey completed in both directions, from slow radio wave to shattering gamma burst, from the light that warms to the light that reveals to the light that breaks. You realize something that makes your breath catch just slightly. It's all the same thing. All of it. Radio, microwave, infrared, visible, UV, X-ray, gamma. It's all light. Just different frequencies, different dances of the same electromagnetic wave. You feel a quiet awe settle in your chest. Because now you see it. Light isn't a line. It's a language, a spectrum of expression, from communication to color to danger to beauty, from warmth to memory to message to mystery. You close your eyes for a moment, just to feel how much of it still reaches you even then. It's still there, even in the dark behind your eyelids. Photons are striking your skin. Your body is glowing faintly in the infrared. Your atoms are holding in place because photons bind their electrons. Your very shape is legible because light makes contrast possible. You aren't separate from light. You are made possible by it. And in that thought, you feel something gentle and enormous, a kind of cosmic kindness. Not because the universe is soft, but because it offers you this one constant: light moves. No matter how far, no matter how long, it moves. And that is enough to see, to know, to wonder. You stand quietly, still wrapped in the echo of the last realization that you are not merely a witness to light, but a consequence of it. The room around you has no walls, no floor, no ceiling, just a vast, gentle hum, as if the entire electromagnetic spectrum had decided to rest for a while. A space of stillness, where every form of light you've explored sits folded inside your memory like pages in a well-worn book. You take a step forward and feel the shift again, not through time this time, but through scale. You're shrinking, softly, like the reverse of growing up. The world expands around you, atoms becoming rooms, molecules becoming cities. You're diving inward now, into the heart of light's relationship with matter. Before you, a single atom pulses gently. You drift closer, smaller, until you're floating just outside the electron cloud. And there, in the blur of probability and motion, you begin to see what it means for light to interact. An electron absorbs a photon and jumps. Not metaphorically, it literally moves from one energy level to another, like stepping up a stair carved from pure possibility. And when it drops back down, it releases a photon, its own little flare, carrying away the exact energy it borrowed. This is how neon signs glow, how the northern lights shimmer, how your TV makes color, electrons catching photons, letting them go. You float through this electric dance for a while, watching billions of these exchanges happen in silence. Each photon has just the right energy, no more, no less, to provoke a change. Too little, and nothing happens. Too much, and the electron escapes entirely. The rules are precise, but the beauty is boundless. You drift downward again, deeper into a molecule this time. It vibrates gently, like a taut drumhead touched by a feather. Light enters, not to excite electrons, but to stir the bonds. This is infrared absorption, and it's how you feel warmth. Not because the molecules themselves are hot, but because they're dancing a little faster, just enough to jostle the nerves in your skin. You think of sunlight on your arm, of warm laundry, of holding a mug of tea in cold air. All those sensations begin here, in these tiny dances between energy and matter. And still, light is the messenger, always the one delivering the invitation. You pass through the molecule and find yourself back among atoms, this time within a crystal lattice. The atoms here are locked in place, aligned in perfect grids. When light hits this structure, it doesn't pass through as usual. It reflects, refracts. Sometimes it splits. You walk alongside a beam passing through a diamond, and you see the rainbows emerge, clean, ordered, elegant, each color bent at a slightly different angle. The diamond didn't invent the color, it just spread the light out, like a careful hand fanning a deck of cards. You remember that materials don't just shape light, they're shaped by it. Glass is transparent because its electrons don't absorb visible light. Metal is shiny because its electrons reflect photons back almost perfectly. The color of anything, the green of leaves, the blue of jeans, the pink of a seashell, isn't in the object. It's in the light the object refuses to keep. And that means everything you see is, in a way, light's leftovers. What isn't absorbed, what is allowed to bounce back to your eyes. You sit with that for a moment. It's funny, isn't it? that the color of the sky is not the sky's doing. It's the scattered blue light, the part that couldn't travel straight, the part that got lost and found its way to you. Scientists still debate whether color is something that exists objectively, or something our brains create to make sense of different wavelengths. But whatever the answer, the experience is real. You know blue when you see it, and you know that it's made of light taking the long way home. You rise and walk across the lattice, through materials both familiar and strange, through soap bubbles and opals, through beetle wings and oil slicks. You see interference patterns, ripples of color caused not by pigment, but by thin layers of material bending light into harmony or dissonance. In these moments, light becomes art, not drawn, not painted, interfered with. The rules of physics make the brush strokes. And then, just as you begin to lose yourself in the colors, they all fade. The scene dissolves into gray, not dull, just neutral, balanced, empty. You're back in a clean white space, and for the first time in a while, the light around you seems undecided. It has no color, no temperature, no movement, until a voice, soft, not speaking but implying, reminds you of something important. There's one final place light hides, not in stars or beams or heat, but in time. You turn slowly and see a clock. It's not ticking, it has no hands, just a faint glow at its center, pulsing precisely, like a heartbeat in slow motion. This is not an ordinary clock, it's an atomic clock, the most accurate timekeeping device we've ever made. And it doesn't run on gears or springs. It runs on light, more specifically, on the frequency of photons emitted when electrons in a cesium atom change energy levels. This frequency is so precise, so stable, that it defines the second itself. Not about a second, not roughly, but exactly. You walk around the clock and see the display, the second being counted, not by motion, but by resonance. Light is the metronome. Light is the pulse. Every second of your life, every minute, every hour is calibrated against a flicker so faint you'd never see it. And yet, it keeps our entire world synchronized. GPS satellites, internet timestamps, global trade, space navigation, all of it depends on this quiet flicker. This single color of microwave light, pulsing invisibly inside a metal chamber, keeping time better than any bell ever could. And just like that, light becomes order, not just what you see, not just what you feel, but how you measure when you are. You take a step back and let the realization settle in. Light defines time. It doesn't just travel through time, it measures it, not by accident, by nature. You place your hand over your chest, where your heart beats on its own rhythm. You don't feel the light inside you, but it's there, in your cells, in your circadian clock, in your brain's understanding of day and night. Even in your sleep, your body listens to light, follows it, trusts it, and maybe that's what makes it so astonishing. Light doesn't just illuminate the world, it organizes it. You remain standing before the atomic clock, mesmerized not by its glow, faint as it is, but by what it represents, not just timekeeping, but trust. Entire systems, entire societies lean on this gentle rhythm, this light-based pulse that never skips, never hesitates, never needs to be wound. It doesn't race, it doesn't drift, it just is. You reach out and place your fingertips near the glowing core of the chamber, not to touch, but to acknowledge. This light isn't fast or bright or dramatic. It doesn't cast shadows or dazzle your eyes, but it defines the seconds you live inside. And somewhere in your mind, a door creaks open. A question tiptoes in. If light can measure time, what does that make time? The room begins to fall away again, slowly this time, like a curtain being drawn back. The clean edges of the laboratory dissolve into a vast and unfamiliar landscape. You're standing on the edge of something deep, not a cliff, but a horizon made of change. This isn't a place in space. It's a place in time, a point where past and future lean together and light slips between them like a messenger running through a crack in the door. You take a step forward, and suddenly, you're surrounded by clocks, not ticking loudly, not even moving in unison, but glowing. Some pulse slowly, some so fast you can barely detect it, and others sit entirely still. These are not clocks as you know them. These are clocks made of motion, of atomic vibrations, of decaying particles, of shifting orbits. Each one keeps time in its own way. Some are governed by biology, your heartbeat, your breath, the firing of neurons. Others by physics, the spin of a pulsar, the decay of a muon, the flicker of cesium, and yet, every one of them is connected to light, to a photon's journey, to how long it takes something to move from here to there. You begin to understand something subtle, something deep. Time is not separate from light. In a way, it is light, or at least, it is revealed by it. Time isn't some ruler outside the world. It's built into the very fabric of what light does. Scientists still debate whether time flows, or whether it's an illusion of perception, whether the past and future are real, or whether there's only ever now, stacked like film frames waiting to be projected. But whatever time is, light makes it visible. You move through the field of clocks, each one marking a different kind of rhythm. A coral reef, glowing gently, expands by millimeters each year. A glacier cracks and groans on a time scale too slow to hear. A heart in the womb thumps for the first time. A star pulses in a far-off galaxy every 43 milliseconds. You pause at the last one. The pulsar. It sits on the edge of a painting that looks almost still, until you realize the pulses are real. Each beat of light, perfectly spaced. No human built it. No earthly clock could rival it. And yet it marks time with astonishing precision, just a collapsing core of a dead star, spinning endlessly, beaming photons across space. You listen for a while, not with your ears, but with your attention. Pulse, pulse, pulse. It's beautiful. You close your eyes and imagine a photon launch from that pulsar. It flies through space for thousands of years, unbothered, untouched, traveling straight until it hits an observatory, a sensor, a pair of waiting eyes. And in that moment, you know when? That's what light does. It brings you when as much as it brings you what. The flicker of a candle tells you not just where the flame is, but when it was lit. The sparkle of a star isn't just distant in space, it's distant in time. You stand now in a dark hallway lined with mirrors. But these aren't for reflection, they're for delay. You watch a single pulse of light enter the hallway. Bounce, bounce again, then again. Each mirror placed just far enough apart to let you see the spacing of time. There is no sound, just a soft pulse gliding forward, touching mirror after mirror. Each bounce is a second, each flash, a quiet little now. And you realize something oddly comforting. Time isn't rushing at you. It isn't slipping away. It's arriving, one photon at a time, each carrying the present into view. You step aside and let the next pulse pass you. Then another, then another. There's no panic, just movement, steady, inevitable, kind. Then something shifts. You find yourself in a room without mirrors, without walls, without anything at all, just light, all around you, not pulsing, not streaming, just everywhere. This is the speed of light not as a concept, but as a boundary, the edge of knowability, the fastest anything can be, the point at which time stops flowing for the traveler, for the photon itself. The journey from one star to another is instantaneous. There is no delay. There is no clock. Because light doesn't age. It moves through time, but is not moved by it. You reach out, slowly, and imagine being light, not metaphorically, but genuinely. To exist without a ticking clock, to see space stretch ahead and instantly be there, to move forever, without waiting, without weariness, without time. It's strange, but also peaceful. You return now to a more familiar place, a small room with a window, looking out at the early light of dawn. The colors are soft, grays, blues, the faintest peach. Light is entering the room slowly, like it's taking its time. You sit in a chair by the window and just watch. No lasers, no equations, no clocks, just morning light. And suddenly, all the theories and diagrams and waveforms melt into something simpler, something quieter. Light has traveled billions of miles to reach this moment, through atoms, through glass, through time. And it's landed here, on the edge of your vision, warming the air. You breathe in, you breathe out, and time continues. You sit in the quiet morning light, the kind that doesn't demand anything of you. It just arrives, gently, unhurried, laying itself across the floorboards and the windowsill as if to say, "Here I am, again." There are no alarms, no equations, no spinning mirrors, just photons landing softly, one by one, making the ordinary glow. You let your eyes trace their paths, how the light shifts across the room, how it slides down the curve of a coffee mug, rests on the edge of a windowsill, pools faintly on your skin. It doesn't feel scientific, but you know it is. Every reflection, every warm sensation, every color is light revealing the world, not just showing it to you, but participating in it. And somehow, the more you understand, the more beautiful it gets. You close your eyes for a moment and feel the warmth without needing to look. You know the sun is just above the horizon. You know the photons touching your skin were born in its core over 100,000 years ago, working their way outward, scattering, ricocheting, until they finally escaped and hurtled across the solar system at light speed, only to end their journey here, on your arm, on your cheek, on this morning. You open your eyes and see the light differently now, not as something separate from the world, but as the shape of the world itself. Light isn't decoration, it's definition. Without it, outlines fade, boundaries blur, motion becomes meaningless. You rise slowly from the chair and step toward the window. Outside, the day is beginning. The light stretches across rooftops and trees, spills into alleyways and shop fronts. But it doesn't just illuminate things, it activates them. It pulls petals open. It nudges animals out of hiding. It kick-starts your own brain, nudging molecules and hormones, shifting your sense of awake. You realize that your entire body responds to light not just through sight, but through rhythm. The light enters your eyes and strikes specialized cells, not for vision, but for timekeeping. These cells send signals to a part of your brain that tracks your circadian cycle, your inner clock. It tells your body what time it is, when to sleep, when to eat, when to be alert, when to dream. Scientists still debate whether the circadian rhythm evolved directly from light sensitivity, or whether it emerged from something deeper. But one thing's certain: light tells time, not just with clocks, but with you. You step outside. The sidewalk is still damp from an early rain, and the light catches every puddle, every glint on a parked car, every droplet on a blade of grass. The air smells like beginning, and for a moment, you see it all in layers. The visible light that lets you walk without tripping. The ultraviolet that helps flowers know when to open. The infrared you can't see but feel on your skin like a whisper. The entire world choreographed by light. You pass a storefront, and the glass warps your reflection. It's not strange anymore. You know that glass doesn't just let light through. It slows it, bends it, holds it just long enough to shift its path. That bend makes rainbows. That delay makes lenses. That redirection shapes how you see your own face. You smile, and your reflection smiles back, just slightly delayed. Around the corner, a traffic light turns green. You know it's just a signal, coded light interpreted by rods and cones and then by habit. But even so, it moves people. It sends a wave of motion rippling through the intersection, one beam of green photons, and suddenly tires are rolling, brakes lifting, shoes stepping forward. Isn't that wild? That a tiny change in color, driven by light, carries that much power? You keep walking, past street lamps that haven't yet turned off, past a bus stop glowing faintly with backlit advertisements, past windows full of warm kitchen light and cool screens and glowing fridge interiors. You see it now more clearly than ever before. Our entire world is wrapped in light's language. It tells us where to go, what time it is, what's safe, what's dangerous, what's beautiful, what's true. You pause beside a tree and look up through its branches. The sunlight spills through the leaves in a pattern too perfect to be accidental. Shadows and highlights move in sync, painting the ground with quiet texture. You raise your hand and let the light draw shapes between your fingers. You remember being a child and doing this, playing shadow puppets on the wall, moving your hands until the light made something more than they could on their own. It's the same now, but with understanding layered on top of wonder. The science didn't erase the magic. It deepened it. You walk a little further and stop at a crosswalk, watching the light play off the chrome of a bicycle handlebar. It flickers slightly, catching your eye. You think of how many photons bounce off that curve, how many escape into space, how many land elsewhere, on windows, on people, on wings of birds. None of them know where they're going. They just travel, straight, at the speed of light, until something redirects them, absorbs them, reflects them. You think about how your own body must scatter light like that. Every surface you forget is visible, glowing faintly under the right frequency. You laugh softly, not because anything's funny, but because there's joy in knowing, in finally seeing what was always there. You continue walking, letting the morning unfold around you. Somewhere behind you, the light that touched your windowsill an hour ago is now bouncing off treetops, or being absorbed into asphalt, or reflecting off a bird's wing mid-flight. You'll never know where those particular photons ended up, but you don't need to, because now you understand something simple and true. Light never stops moving, not because it's in a rush, not because it's chasing something, but because that's what it does. It goes, it touches, it changes, it leaves, and in doing so, it connects everything, stars to skin, atoms to oceans, breath to memory. You look up one more time into the growing sky. The sun is higher now, and the light is no longer gentle. It's bright, bold, confident, but still, it carries the same story, the same flicker, the same speed, the same quiet gift. You keep walking, sunlight pouring steadily over your shoulders, washing the city in soft gold. The world has shifted, though it hasn't changed. The light has always been here, cascading over sidewalks, sliding down glass towers, glinting off rivers and phone screens and the backs of insects. But now you see it all as part of one long, uninterrupted journey, a story told in brightness. Your steps carry you through a quiet park, dew still clinging to the blades of grass, where joggers pass in silence and birds throw brief shapes against the morning sky. The shadows are long, but shrinking. The sun climbs a little higher with each breath, each heartbeat, each photon finding its place. You pause beside a bench and sit down for a moment, not because you're tired, but because something in the air has slowed. This moment asks to be noticed, and so you notice. A tree stretches over you, its branches carefully balancing spears of sunlight and fans of shadow. You lean your head back and look up, watching the green canopy shift and flicker with the breeze. The light scatters in thousands of directions, some beams passing straight through, others catching on the waxy surface of leaves, still others bouncing from branch to branch in a slow-motion kaleidoscope. You blink, and suddenly, you're no longer looking at a tree. You're looking at a light experiment, one that's been happening for millions of years. Leaves absorbing photons, chlorophyll turning sunlight into sugar, photosynthesis, the original alchemy. It's easy to forget that sunlight doesn't just warm the earth, it feeds it. These leaves are alive because of light. So is the grass. So is the apple hanging quietly on the other side of the tree, its skin catching the morning glow. That apple grew because photons struck cells and triggered molecules. It exists because light arrived. And now, it reflects some of that light back at you, offering both color and invitation. You pluck it gently from the branch and roll it in your hands. It's cool. You know that the sugars inside it, sweet, subtle, quietly complex, were formed by sunlight stored in chemical bonds. To eat it is to eat light, condensed, transformed, translated into something soft enough to hold, sweet enough to taste, ordinary enough to forget. But you don't forget. Not now. You take a bite and feel the texture, the tang, the sudden burst of juice, and beneath it all, the quiet memory of photons. Scientists still debate whether photosynthesis is the most efficient process nature ever designed, or whether it's simply the most elegant. But either way, it's a reminder. Light gives more than vision. It gives life. You sit a little straighter, watching the way the sunlight cuts through the park. Children play in the distance, chasing each other through gold-spun air. A dog runs beneath a fountain of light, pouring between two old trees. A couple holds hands beneath a flowering arch, petals catching the sun like stained glass. Everything is responding to it, not just plants, not just people, everything. Light doesn't ask to be noticed, but it's always shaping what you notice. You rise from the bench and walk again, this time past a small lake, its surface sparkling like a field of shifting mirrors. Each ripple catches a beam of light and tosses it skyward, where it dances for a second before fading into the blue. You watch your own reflection ripple and bend with the water. It doesn't look like you exactly, but it belongs to you all the same. That's what light does. It makes connections between what is here and what appears, between the thing and the image, between the real and the visible. You step onto a footbridge that crosses the narrowest point of the lake. The boards beneath your feet creak softly. You pause at the center, leaning against the railing, looking down. The water below reflects the clouds, the trees, and your face all at once. It's not a perfect mirror. The wind shakes the surface, makes your jaw twist slightly, your eyes wobble, your outline blur. But somehow, that feels right. You are not fixed. You are not still. You are a reflection too, always changing, always in motion, and light doesn't mind. It carries you as you are. You continue across the bridge and into a shaded grove. The light here is dappled, fragmented, broken by branches and reshaped by motion. It reminds you of the experiments with pinholes and lenses, of early scientists casting light through tiny apertures to trace its path across paper and walls and theories. You kneel and place your hand against the trunk of a tree. The bark is rough. The ground beneath you smells of damp leaves. A shaft of light cuts across your fingers, flickering slightly as a leaf shifts overhead. You realize, in this moment, that you're standing inside a natural camera. The branches above form an aperture. The light moves through it. The forest floor becomes a canvas. You are both photographer and subject, and the sun keeps painting. The path curves upward now, toward a clearing. You follow it, slow and deliberate, until you emerge into full daylight once more. The sky is enormous. Birds scatter and return. The light pours over the land like a waterfall that never runs dry. You think of every place it's touched, from the surface of ancient mirrors to the back of your eye, from collapsing stars to glimmering soap bubbles, from binary pulses to blossoming petals. Light has always been there, waiting, offering, and suddenly, you feel it, not as knowledge, but as sensation. You are part of the beam, not just watching it, not just lit by it. You are made possible by it, your cells, your breath, your thoughts. And that brings you to one final thought, so simple it nearly slips away. Light is the only thing that lets us see the world, but it's also the only thing that lets the world see us. You stand there in the clearing, the sun high above now, casting clean shadows beneath your feet. The light is sharper than it was earlier, more direct, less filtered by trees or mist or early morning haze. It makes edges clearer, it defines, and yet there's a softness to it still, because now you understand its journey, and knowing that softens everything. You begin to walk again, this time along a trail lined with tall grasses and wildflowers that seem to lean toward the sun without hesitation. They don't need to know about photons or electromagnetic fields. They just follow. They bloom when it's time. They tilt when the light moves. And in that tilting, you see something gentle and wise. You pause beside a patch of sunflowers. Their faces turn toward the sky like worshipers in silent prayer. You reach out and touch a leaf, and it's warm, not from the air, but from the light it's absorbed. You wonder how many photons are landing here every second, how many are being caught, converted, woven into the fibers of life, how many will soon become color or nectar or seed. You step back and let the field exist without you for a moment, just sun, flower, motion, And then, movement in the distance, a shimmer, not a breeze, not a heat wave, something in the air itself. You squint gently and realize what you're seeing. Dust. Tiny particles floating mid-air, catching the sunlight just right. Invisible a second ago, now glowing like fireflies in a still sky. It's stunning. You watch one speck drift down, not quickly but gracefully, like it's in no rush to land. And you know this too, is light's doing. The particle was always there, but only when light strikes it at the perfect angle does it become visible. Not because it changes, but because you do. That's the secret, isn't it? Light doesn't make things exist. It just makes them seen. You sit down on a nearby stone, the sun warming your back, and let your thoughts drift. You think about mirrors again, about how we've used them not just to see ourselves, but to look farther, into telescopes, into microscopes, into realities beyond human scale. Light reflects, yes, but it also reveals. You think about how a mirror, placed just right, can let you see around corners, how it can bounce a photon from a star into your eye, or bounce your own gaze back into itself. You think of the ancient mythologies where light was a symbol of truth, of insight, of knowledge, and now you understand why. Not because it's holy or pure, but because it's honest. It shows what is. It doesn't edit. It doesn't hide. You lie back in the grass, arms behind your head, and stare up into the sky. Not the stars this time, not the cosmic background or ancient photons, but the daylight itself, the sea of blue. You let yourself wonder, like you did as a child, why the sky is blue. And now you know the answer. Scattering. Blue light scatters more easily in the atmosphere than red. It ricochets, bounces, spreads in every direction. It paints the entire dome of the sky not with pigment, but with persistence. Not because it's stronger, but because it's more easily lost. And isn't that a little poetic? That the color we associate with calmness is made of light constantly getting knocked off course. You watch a cloud drift by and catch the edges glowing. The light around it doesn't come from behind, but from all around, from above, from air itself. You begin to see clouds as sculptures in a river of photons, shapes carved not in stone, but in luminance. Somewhere overhead, a plane crosses the sky. A glint flashes off its body, just for a second, and you feel your breath catch. That flash has traveled in a perfectly straight line to your eye, dodging every interference, skipping past atmosphere and haze and cloud to find you. One instant of recognition, one glimmer of shared location, and then it's gone, but you're still smiling. You rise and follow the trail a bit farther, until you find yourself in front of a weathered fence and a quiet hill. You climb it slowly, shoes sinking into warm soil, the sun at your back, and at the top, you pause. Not because of the view, though it's lovely, but because the light here is different, not brighter, not dimmer, just lower. The shadows stretch long again. The gold returns to the grass. You've looped through the arc of the day, and now the sun is beginning to descend, not in haste, but with purpose, with poise. You sit once more, letting the late afternoon settle around you. The world shifts subtly, the greens richer, the blues deeper, the air thick with light made warmer by angle. You realize this is your favorite kind of light, not the light that wakes you, or guides you, or even feeds you, but the light that says, stay a little longer. It stretches across your arms, your legs, your face. It softens hard edges. It tints the world not in neon, but in memory. You close your eyes and listen to the quiet. Not silence exactly, but light has a way of making even noise seem gentle. A rustle of grass, a call of a bird, the wind catching its breath. And somewhere beneath all that, photons still landing, still bouncing, still illuminating every shape, every wrinkle, every pause. You think of the first moment light was measured, the spinning wheel, the notches, the candle. You think of Fizeau, crouched beside his apparatus, waiting to see whether the beam would return or vanish. That flicker, that first moment of disappearance, that was the start of it all. From there, we chased the beam, we mapped it, slowed it, split it, used it to count, to carry, to comfort. And every time, it gave itself freely. Not because it had to, but because that's what light does. It goes, it touches, it tells. You lie back once more, arms wide, the sky an endless canvas overhead. The sun is dipping lower now, and every ray feels like a story arriving just in time. Light doesn't age, but you do. And in the glow of this late afternoon, that feels less like loss and more like participation. You're not racing the light, you're traveling with it. The sun dips lower still, each minute stretching the shadows across the earth like long exhalations. You sit quietly, your body wrapped in the warmth of light that began its journey long before this day ever started. There's a stillness now, not the kind that comes from silence, but from understanding, from knowing you don't need to chase the light anymore. It's already found you. A soft breeze brushes past your cheek. You feel it not just as wind, but as a carrier of subtle change. The temperature shifts, the colors deepen, the insects hum a little louder, a little slower. Everything is preparing, not for darkness, but for transition. The light is not gone yet, but it's retreating, gently, like a curtain falling in reverse. And you watch it. You begin to notice something strange and lovely. As the light fades, the details become richer. Not the kind your eyes crave during daylight, but the kind your mind holds on to. The softness of outlines, the slight bluing of shadows, the way a single blade of grass catches the last golden ray and stands like a sentinel at the edge of day. You walk now, slowly, leaving the hill behind. You take the long way down, letting your feet brush past tall grass and soft clover, each step stirring up tiny flecks of pollen and dust, made momentarily visible in the amber glow. At the base of the hill, the world has changed. It's not night yet, but it isn't quite day either. This is twilight, the in-between, and twilight has its own kind of light. It's quieter, slanted, less insistent. It doesn't chase away shadow. It invites it, blends with it, creates that peculiar feeling of nostalgia for a moment you're still living in. You remember learning once that this light, the kind at dusk, is rich in red and orange wavelengths because the sun is passing through more of Earth's atmosphere. The blue gets scattered out, the longer wavelengths linger, and those longer wavelengths feel familiar, warm, not in temperature, but in tone, as if the light itself knows the day is ending and is offering a gentler goodbye. You sit again on a nearby bench, one you hadn't noticed this morning. It's old, with peeling paint and a slight wobble, but it holds you without question. The light rests on your shoulders like an old blanket, and you feel your breath slow. Your heartbeat settle into a rhythm that matches the fading world around you. Overhead, a single star appears, and then another. Not blinking, not sparkling, just being. You smile softly. You know those stars have always been there, waiting. The light they shed has traveled for decades, centuries, even millennia, crossing unfathomable distances to meet you at this exact moment. It's not a metaphor. It's not a guess. It's physics. You look up and realize the sky is no longer blue. Not exactly. It's indigo now, deepening by the second. A few clouds drift quietly across the horizon, tinted lavender and rust, like brushstrokes on a canvas that's still wet with story. And just above those clouds, the first faint shimmer of the evening star. Venus, bright, constant, beautiful. You feel a gentle thrill, not because it's rare, but because now you know what it is, what it reflects, how it shines. You know the light from Venus isn't its own. It's sunlight bouncing off clouds of sulfuric acid, refracted and softened and sent back across space, into your eyes. And yet, it still feels personal, like it waited all day for this moment. Scientists still debate whether we've truly understood twilight, whether our models account for all the scattering, the refraction, the filtering of atmosphere and particle and angle, but you don't need an answer right now. You only need to look, and looking feels like enough. You rise and follow a stone path lined with soft lamps, each one glowing with a golden filament. They hum faintly as you pass, as if whispering stories of their own. Edison, tungsten, carbon arcs, light bulbs built to imitate fire, to prolong the day, to tame the dark. But you're not afraid of the dark tonight. You step into its edges willingly. Let it wrap around your ankles, then your waist, then your shoulders, until you're walking in shadow with only the path lit before you. Your eyes adjust, shapes emerge, trees become silhouettes, houses become outlines. The world hasn't disappeared, it's just shifted frequency. And you realize something curious. Your body has a night mode. Your pupils widen, your hearing sharpens, your skin becomes more aware. Your sense of time slows, not because time has changed, but because light has. You keep walking, and soon you're passing quiet windows lit from within, kitchens glowing with stovetop light, hallways flickering with soft lamps, a cat perched in the window of a darkened room, watching you with quiet curiosity. It's a reminder, not all light is sunlight. You glance up at a street lamp buzzing above your head, its halo soft and yellow, casting sleepy rings across the sidewalk. The insects know it's there. They gather in silent loops, drawn not by logic, but by instinct. Some scientists think they're following the moon by mistake. Others say it's just a quirk of navigation. Either way, the lamp becomes their moon. And for a brief moment, it becomes yours too. You pass under it and feel its warmth on your scalp. Artificial, but no less real. Light is light, whether from fusion in a star or filaments in a bulb. Whether born in a candle or a hydrogen bomb, it's all made of photons, all part of the same story. And tonight, that story is almost done. The path curves once more, and you find yourself back where you started, your home, your door, your quiet little place on the edge of the world. You stand there for a moment before going in, looking up at the night sky now fully opened. It stretches above you, endless and ancient, dotted with stars whose light has outlived empires. Some of those stars no longer even exist, but their light still does. That's the strange, quiet magic of it. Light remembers. You smile once more before stepping inside, because now, you understand. You are not walking through light. You are walking with it. and it's his walking with you. You step through the door and close it gently behind you. The house greets you with a hush, like it too has been waiting for the light to fade. The glow from a lamp in the corner stretches across the floor in a soft, amber arc. You don't turn on anything brighter. Not tonight. Tonight is for slow transitions, for respecting the rhythm that's been moving through you all day, shaped by sunlight and softened by dusk. You set your keys down. The metallic clink echoes just slightly in the quiet. A mug waits by the sink, still faintly warm from this morning's tea. You wrap your fingers around it, not for warmth, but for memory. You walk it to the table and sit. Outside the window, the darkness settles fully now. The sky has turned the kind of black that doesn't need stars to be beautiful, but the stars are there anyway, punctuating the silence with slow, silent declarations of distance. You glance at the wall clock, not because you need to know the time, but because it feels like the thing to do at the end of a day shaped by light. The hands tick forward, 1 second at a time, each click powered by a tiny current, by electrons, by light trapped in a battery until it's called upon. Even here, in this stillness, light is working. You stand and move to the bookshelf. Your fingers trail along the spines of titles you've read, half read, meant to read. One of them catches your eye, an old volume on optics. The pages are thin and the cover is worn, but something about it feels right. You open it and let the diagrams and sketches greet you like familiar friends. Arrows of refraction, angles of incidence, wave patterns inked decades ago. You sit again, book resting on your lap, and let the drawings pull your mind gently backward, not far, just to the idea that light bends, that it enters one medium and shifts its speed, that it moves from air to water, or glass to vacuum, and in doing so, changes direction, not because it wants to, but because that's how the universe works. You remember experiments, glass prisms splitting white into rainbow, water turning a straight stick into a crooked one, and you think about how much of what we see is not what is, but what's bent, skewed by the rules of reflection and refraction. You think about your day, the beams you followed, the photons that touched your skin, the light that moved through tree canopies and danced on lake surfaces and flickered in dust, and you realize none of that light traveled in a straight line. Not really. It bounced, it bent, it scattered, and yet it arrived. You close the book gently and rest it on the table. Then you walk to the window and open it just a few inches. The cool night air brushes in, carrying the scent of distant pine and city stone, and perhaps the ghost of sunlight, long since faded. You breathe it in, slowly. Deliberately, somewhere outside, a streetlight flickers, maybe from a loose filament, maybe from interference, but it pulses like a heartbeat, steady and slow, casting brief shadows that sway against the sidewalk. You wonder how many kinds of light there are that you can't see. Radio waves humming invisibly through the walls, microwave pulses bouncing between satellites, infrared mapping the world in temperature, ultraviolet illuminating secrets in flowers and feathers and forensic labs. The full spectrum surrounds you, and you only perceive a sliver, and somehow that makes the visible part feel even more precious. You move away from the window and turn off the lamp. The house darkens instantly, leaving only the glow from outside, silver traces from the moon, warm flickers from porch lights, the faint blue hue of distant LED clocks. You let your eyes adjust again. Let your brain do what it's done for millennia. Make sense of shadows. Find safety in dimness. Ease into rest. And slowly, you walk toward your room. The hallway stretches quietly in front of you. Each step falls softer than the one before. The walls, once pale in daylight, now wear a dusky tint, like a memory of color rather than color itself. Your hand brushes along the edge of a table, catching on the texture of wood warmed by hours of sun. In your room, the air is still. The bed waits, its sheets cool, its blankets heavy with promise. You sit on the edge for a moment, letting your shoulders drop, letting your mind settle, and then, without effort, you lie down. You stare at the ceiling. Nothing moves, but you know that light is still arriving. From stars, from planets, from long-dead galaxies. Photons traveling for millions of years to reach this small room, this ceiling, your closed eyes. That's the beauty of light. It doesn't need to be seen to be present. And maybe that's the lesson it's been offering you all day. Not about speed or wave-particle duality, not about mirrors or optics or measurements, but about presence, about showing up, even quietly, about reaching across unimaginable distances and still arriving with something to offer. You pull the blanket over your shoulder, and in the darkness, you see more than you expected, a soft halo around your thoughts, a gentle echo of brightness behind your eyelids, the memory of sunlight resting in your skin. And you know, without doubt, without words, that light never truly leaves. It just waits for you to notice it again. And now, the light has gone quiet. It hasn't vanished, just lowered its voice, like someone tucking you in with a whispered goodnight. The house is still. The sky outside has surrendered to night completely, a soft canvas of velvet black stitched with stars that blink as slowly as you're breathing. There's nothing left to chase, nothing left to learn right now, not because the story is over, but because it's content to pause here, with you, to wait until you're ready again. Tonight, you walked with photons. You felt the pulse of sunlight in leaves, the shimmer of dust lit just right, the slow bend of shadows as the day exhaled. You followed light from a spinning wheel to the edge of the sky. You let it soften your steps, shape your thoughts, and lead you gently to this moment. And now, your body is heavier. Your eyelids drift like clouds at dusk. Your breath is quiet, your hands still. The world has faded into soft outlines and warm memory. There's no need to hold on to anything. Let the light carry it now. Let yourself rest, sleep, slow and unhurried. Waits on the other side of this silence. You're ready.